Okay, so it seems like everyone is joining. I will admit people if there are more people that join. But hi everyone, thank you so much for participating in our 2022 Math Invitational for Girls competition. We are so excited to see you guys here. And I want to pass it to Amanda, who will give a short introduction.
Hi everyone. So once again, thank you to everyone for joining. I hope that you guys had fun with the test. I know we definitely had a lot of fun making the test. And so with that being said, I hope that everybody today can stay for both the award ceremony and listening to our wonderful speaker. She's such a great person and also a great professor. So I hope everyone will enjoy that as well. If you guys had any thoughts about the test, like if it was too hard or too easy, or just any general ideas, if you thought it was fun, then you could go ahead and put that in the chat. We're really open to reading what everyone thought about it and about the award ceremony in general. So without further ado, I'll hand it back to Marissa for the introduction and also a short overview of what we're going to be doing for the entire Zoom today.
Okay, thank you. So today we are first want to start off with introducing our MIG team, and then we will welcome our guest speaker, Dr. Shira Viel. And afterwards, we'll have a short Q&A with Dr. Viel, and you can leave questions for her in the Zoom chat if you'd like. And then after that, we will have the awards announcements, and then lastly, we will have some closing remarks. So I would like to introduce the MID team. First of all, I'm Marissa Liu, and I'm so happy you guys are here. We worked really hard on making this competition possible, and I hope you enjoyed this Saturday doing our MIT competition. Hi guys, I'm Sydney. We've had a really great turnout this year. I'm seeing so many people in the Zoom and the award ceremony. It's so great seeing you all come out on this Saturday to compete and just learn math for a little bit. Hi everyone, my name is Shira. I'm really excited you guys all participated. No matter how you think you did, I think you did something really impressive by even spending your Saturday like this. I know it's not easy to give up your weekend to do something with math, but I'm really glad you guys chose to do that.
Hello, my name is Jerry Shao. I'm a problem writer for MIG, and I hope you all had a fun time doing the test. And I also hope you all have fun with the events that follow.
Hi everyone, my name is Annie Wu, and I really enjoyed that you guys decided to compete and make this year.
Hi everyone, I'm Emily Zhang, and I hope everyone enjoyed the fall.
Okay, awesome. So now I'm so honored to introduce our guest speaker, Dr. Shira Viel. So actually one of her calculus students kindly recommended me to her. Angela actually took me on a tour of Duke last summer. I really enjoyed it. So Dr. Shira Viel is the assistant professor of the practice of mathematics at Duke University and works primarily in introductory undergraduate math education, including teaching, research, and curriculum development. Dr. Viel is passionate about making math as welcoming and inclusive as possible, with interests in the student sense of community, alternative assessment methods, and the training of graduate student instructors. Her other research interests are drawn from her PhD work in algebraic combinatorics, counting interesting things and doing algebra with pictures. Beyond education and mathematics, Dr. Viel enjoys being outdoors, baking, crosswords, ultimate frisbee, and spending time with her family. We will have a brief Q&A session after Dr. Viel's presentation. So if you have a question, please leave that in the Zoom chat, and then I will be passing it to Ira to read those aloud and then facilitate Q&A. And without further ado, please join me in welcoming Dr. Viel. And let me stop sharing my screen real quick.
Thank you all so much. It's such a pleasure to be here, and I'm so excited that you decided to spend your Saturday doing math and listening to me talk about math. And the organizers have put together an amazing event, and it's really wonderful to be here with you. I wasn't quite sure what to talk about today, so I decided that I would just talk to you about myself at first and my sort of meandering path to mathematics. And then if we have time, I might show you some of what I meant in that introduction by counting interesting things and doing algebra with pictures. So I'm Shira, Dr. Shira Viel, and that's pronounced Shira like Shira, Princess of Power. for those of you who've seen the reboot on Netflix. And I am at Duke University. And so this is me, not that much younger than you are now, in 4th grade. And this was when I first started falling in love with mathematics. And I don't know if you can read what it says there, but this is actually a quote from my self-reflection in 4th grade where I said, I feel like I've gotten much better in math and I like it. My greatest accomplishment is probably when I started to enjoy math. And the reason I wanted to share that with you is because before 4th grade, and I know I can't see all your faces, but I felt like I was just doing a lot of computation. I was doing these 100 problem sheets of multiplication. Have any of you done that before? To do like 100 multiplication problems in 10 minutes? And I wasn't very good at that. I wasn't very fast at computing, and I didn't think it was very interesting. It seemed like you just sort of, once you got the rule, you just did it over and over again. And I wasn't that into it. And then in 4th grade, I had a teacher who started doing these problems of the week, like the types of problems that you saw on your competition earlier today, which were a little more interesting and thought-provoking. And that's when I thought, oh, this is kind of creative. I do like it, and I could be good at it as long as I don't have to be really fast. And so that was a turning point for me. And for those of you who are interested in this picture came from my colleague Lillian Pierce at Duke, who is fantastic and created a whole art piece of different people in the Duke math department and how they came to math. So I linked to that below if you want to take a look. But that was how I first became interested in math. And then the next big turning point for me was in high school. So a little bit older than you are now. And I don't know if any of you know how to raise your hand in Zoom, but maybe I can see you if you raise your hand. Who's heard of Harry Potter? Yes. Well, Harry Potter is amazing and was a huge deal, particularly when I was in middle school and high school. The books first came out when I was in middle school. And I had an amazing calculus teacher in high school who told us, I don't know whether any of you have taken any calculus before, but what happens when you take the derivative of a function is you kind of knock it down. It gets smaller and smaller and smaller. And my teacher took us aside one day and he said, there's this really special function, e to the x, and the derivative of it is itself, like a phoenix rising from its ashes, because even when a phoenix burns down, it comes right back. And I thought that was incredible mathematically, and that there is a connection to Harry Potter. And I decided, okay, I'm going to keep taking math in college. I don't know what I'm going to major in, but this is enough. I want to keep doing this subject. And I'm sorry, I'm outside right now. My kids are taking a nap inside, and I don't want to wake them up with my loud voice. So if you see the wind blowing my hair, that's why. Okay, so that was high school. Then I did something kind of weird. I didn't go right to college. And that's becoming more common now, but I didn't know what I wanted to study. And I really, really wanted to be a professional baker. So I took a year off and I worked for a caterer, and I volunteered at our children's museum. And that was wonderful. I got to explore those different sides of what I was interested in. And eventually made my way to college at Rice University in Houston, Texas. And I had no idea what I wanted to major in. I just took classes that were interesting to me, and I eventually ended up with a degree in math and in theater. And still didn't know what I wanted to do, but loved my time there and loved being in class. Then, and I feel like probably some of the organizers on the Math Invitational for Girls team have heard this before. When you don't know what you want to do and you like math and you're creative, but you have no idea what you want to do, people tell you, oh, you should be a management consultant. So I tried that. It was not for me. Wonderful, brilliant people, but the corporate world was not, I missed teaching, I missed being in a classroom, and I missed being weird. And it's harder to be weird in the corporate world. So I tried to bake again. I actually sent out my resume, having just graduated college, to 40 bakeries in Houston, Texas, where I went to college. And told them I had a major in math and theater and all these academic qualifications, and would they just take me on as an intern, and didn't hear back from anyone. So I found another job and I worked in software for a while. I've always known that I wanted to do something related to teaching and education. And I worked for a nonprofit mathematical education software company, which I loved. And I got to work with middle school students, just like you, as well as elementary school students, both in the classroom and in training their teachers. And I loved that a lot, but on the weekends, I was volunteering, leading a math circle. Have you all heard of math circles? It's kind of like fun math on the weekend. And it's something I highly recommend seeking out where you are if you have them. But I love doing that, and teaching folks like yourselves about cool math made me miss learning it myself. And that's when I decided to go back to school. But at that point, I'd been out of school for a couple of years. And people often think, regardless of what your career path is, you're probably already thinking about what you want to be. And you're thinking, well, I have to get into this college. And then from college, I have to get into medical school, or I have to get into law school, and I have to go into graduate school. And it all is very linear and planned out. And that's not what I did. And that's okay. I ended up at Smith College, which is a women's college in Northampton, Massachusetts. And they have a Center for Women in Mathematics. And they pay you for a year to figure out if you want to go to math grad school. That is what the program is. You get to take graduate courses. You meet women who have all different roles in mathematics, in industry, and academia, and get to try your hand at math research, which is a very interesting thing, which maybe I'll get to talk with you all a little bit about today. But I did like it. And from there, I made my way down to where I am now in North Carolina. And I got my master's and PhD in mathematics at North Carolina State University. Along the way, while in grad school, I did some other things too. I wanted to share that I was still baking. And what you might see there is one of my proudest baking accomplishments, which was a wedding cake for 200 people. And that involved a lot of math. I had to do a lot of recipe computation because recipes aren't written for 200 people. And I was combining different frosting and cake and decoration recipes, and they were all scaled for different amounts of people. And so that was a lot of fun. But what you may not be able to see, because I kind of cut it out there, is what's going on right here. After spending all this time making this theoretical model for the cake and building it, and it was 3 hours before I was to get married, I assembled the cake and it was tilted. And it was starting to fall. And luckily, my husband is an engineer. And so he rigged up a little shim and propped it up, and we were good to go. But the moral of that story is theoretical math is wonderful. And you need some applied stuff too. So don't forget about applying all your math to the real world as well and putting it into the real world context. And I also kept baking in a mathematical sense as well. That is a cake that represents one of my results from my PhD dissertation. And then I made it to where I am now, which is at Duke, where I'm an assistant professor of the practice of mathematics. And it's a wonderful combination of all of my interests. I get to teach, that's my main responsibility, and help develop new courses and help introduce math to people who aren't that interested in it and develop the interest of those who are already excited. And in addition to doing a little bit of the research that I was trained in, I am starting to get into math education research and think a lot about how people learn mathematics and how people feel welcomed in mathematical environments, particularly how do girls and women feel in mathematical classrooms, and how to help you all feel like you belong. Here's some pictures of some things I do now. You can see I'm still baking, and I'm still math baking. Does anybody know what this one? You've probably all heard of a pie. So that's not too strange. Anyone know what this is up in the top left? Either mathematically or culinarily. You can type it into the chat. Raise your hand.
Tart. I feel like that looks like a tart, but it could be something else.
This is it's called a Sierpinski Taschen. You can Google it online. Sierpinski Taschen, and a Sierpinski triangle is a kind of fractal. You can see that there's a triangle with smaller triangles inside, with smaller triangles inside, with smaller triangles inside, which is a fractal, a mathematical object. And it's also a Hummentaschen, which is, someone had it in the chat. Wonderful. Yes, fantastic, Caroline and Lainey, exactly. And it's also a Hummentaschen cookie. But yes, it is basically a tart. So that's an excellent guess as well. Well, thank you all. I wanted to pause to see if you had any questions about anything that I just said or anything at all. I'm happy to answer questions. And again, my name is Shira, like Shira, Princess of Power.
You guys can go ahead and type those questions in the chat. And while we're waiting for those questions to be coming in, I guess we'll start with some questions that the MIG team had for you. So could you give us like a brief overview of what algebraic combinatorics are, including surface and orbifold models? Because we're all like in that middle.
Well,
It's math,
so
but more.
I don't know about yes, great question. So the name of my field of training is algebraic combinatorics. Let me write that down. It's a mouthful for sure. But I bet a lot of you already know some of the parts of this. There's the algebraic part, which is algebra. And algebra is just studying structures or working with variables. And probably for most of y'all here, it's the working with a variable. And what makes working with variables so powerful is all of a sudden, instead of just solving 2 times what equals 6, and you can phrase it in terms of a variable, like, and say 2 times x, and then you can solve for the x is the 6 over 2. And then more generally, if we have 2 times x equals y, then that just means, oh, okay, x equals y over 2. That was a lot of hand wavy without my writing anything down, but algebra is study of structures, and it's being able to generalize. Like all the things that we know are true about counting numbers, we want them to be true about other things, and then we want to be able to talk about them generally. That's algebra. We'll call this structures. And then combinatorics just means counting. Truly, fun ways to count. And you've probably seen some of this before. Like if we have 3 friends, have to take turns, they're all waiting in line to get a burger. 3 friends getting burgers. How many different ways can they wait in line? Like in how many different orders? And if the 3 friends are A, B, and C, like Abigail, Brittany, and Carolyn, then we can think about different ways to order those 3 different people. And does anybody know how many different ways they can wait in line? We could try listing them. There's, well, if we decide Abigail could go first, and then Brittany could go next, and then Carolyn, or maybe it could be Abigail, and then Carolyn, and then Brittany. Are there any other ways Abigail could go first? Well, no, because then there's no other ways to order the other people. And so you can sort of systematically list things out. So then what if Brittany went first? Well, then it could be Abigail next, and then Carolyn, or it could be Brittany and then Carolyn, and then I can't even remember the other first names, Abigail. Or the last possibility is that Carolyn goes first, and then it could be Brittany and then Abigail, and then Abigail and then Brittany. So there's 6 different ways. So this is a way of counting. And this comes up a lot. You might have heard the words permutations and combinations. So one way, the answer is there's 6 ways, which is sometimes also known as 3 factorial, which is 3 times 2 times 1. And listing those out wasn't so bad, but it would be even nicer to have a more concise way to think about it. And one way to do that is to say, okay, there's 3 different spots in line. Let's choose who goes first. Well, there's 3 friends. One of those 3 friends has to go first. But once we pick who goes first, there's only 2 friends left who can go second. Let's pick which of those 2 friends goes second. And then there's just 1 friend who has to go third. And so this is a way of sort of counting things cleverly. And algebraic combinatorics is counting things that have an interesting structure. And my advisor described the area of mathematics that I was working in, which was sort of an algebraic combinatorial approach to cluster algebras and orbifold models, as doing algebra with pictures. So I like to draw a lot of pictures. And I see we've got a lot of questions in the chat that people were answering. Oh, I'm out of practice with Zoom. Fantastic, everyone. Thank you all so much. Yeah, so the very broad, or I should say brief introduction to the math that I did in my dissertation, which is now a long time ago, but I can maybe talk you quickly through it, is figuring out different ways to break up a polygon into triangles. And how am I on time? Should I take more questions? Should I stop? I know you have lots more to do.
No, you're okay. We can keep going.
So, all right. How many ways can you split up a triangle into a triangle? 1. Not very interesting. How about a square? We could put that diagonal in. Are there any other ways? Yeah. Ooh, I'm seeing interesting. Some people are saying 4. And I wish I could see y'all and have you talk. There's 2. We can sort of have this diagonal or that diagonal. And that's not so bad, but things start to get even more complicated when now we've got ourselves a pentagon, a 5-sided thing, and then it's not even clear, how do we know if we have them all? And so something we can do is sort of think of flipping. So we could take this arc, this line, which is cutting up a triangle, and then we can flip it, because when we flip it, that gives us a new triangulation. But we could have also chosen to flip the second arc. So we'd keep the original one, and then we'd flip this green one, and that also gives us a new triangulation. Do we have them all? Okay, well, what if instead in here, we now flip this arc? That was a terrible pentagon. Here we go. So we still have that green arc, but we're flipping the yellow arc. That gives us this one. Do I have them all? Well, no, I could finally then flip this last arc here. And that would give me this triangulation. And that's all of them. And you can see that the way I'd get to this next triangulation, or splitting up into triangles, is by flipping that last arc. So there's 5 ways to split up or to triangulate a pentagon. And this goes on, and there's formulas, and these numbers that I'm writing down are amazing numbers called the Catalan numbers, which you should absolutely Google and Wikipedia to find out more about. But it turns out that something you can do is you can associate variables to these arcs. And when you flip them, it corresponds to algebra, multiplication and division. And there's whole structures you can describe just by drawing little pictures of triangulations of pentagons. And that's an introduction, very broad, into that then you create a cluster algebra from it. But I loved that part about it. I spent a lot of my PhD just drawing pictures and getting intuition from cool pictures.
That's amazing. I see someone from the chat. Whoa, I agree. That's pretty amazing. Much for that introduction. I think that was really educational for all of us. I mean, I'm in pre-calculus, and to be honest with you, I didn't fully know about that. So I was happy to learn all about that. So the next question we kind of wanted to ask you was about your experience as a woman in mathematics. And I know you've been exploring math, through your undergraduate. You were at Smith College's Center for Mathematics. So, as a woman in a field that's mostly men, how do you feel that affected your experience? And, are there any particular examples or cases that you felt like it put you at an advantage or a disadvantage, or something you'd like to kind of share with all these young girls on here interested in math?
That's a great question. I think when I was the age of your participants now, so in middle school, I actually felt like women were the best at math because I was in a little advanced math class among my grade, and everyone, it was five girls. Because we happened to be the ones who were chosen for this class. And so I just assumed that was the case. I didn't really know many people in math. My parents are not STEM at all in their career choices. And so that was the model. And our teacher was female as well. And when I got into high school, I still felt I carried that sort of confidence in myself forward. And so I didn't feel advantaged or disadvantaged at that point. But then when I got to college, I knew that I liked math, and I signed up for this honors calculus course. Coming into, and those of you who are just starting in at a new middle school or will be starting in a new high school, you've had that experience of being in a brand new place and trying to figure out who you are and where you fit and what's best for you. And so I signed up for this class, and I went for the first 2 class sessions, and there were only 2 other women in this class of 35, and it felt like everyone had already taken the material. I felt like everyone in that room knew more than I did. They were way more qualified, and they also almost all happened to be male. And so I dropped the course, and I didn't stick it out. And for a while, for that whole first semester, then I thought I'd given up I didn't have a chance to be a math major because this was the course you were supposed to take if you wanted to be a math major, and I was too intimidated. It turned out though that I did end up, there's other paths. I ended up becoming very good friends with one of the other girls in that class. And that, I think, was one of, I would not have made it through without her. Finding a good friend with whom you can commiserate and do problem sets together. I think not just in math, but in all fields in STEM, you're working a lot of problems because that's how you learn the material, you get your hands dirty. And having someone to talk through those problems with is tremendously valuable. And someone who you're not afraid to ask if you don't understand. Because everyone doesn't understand. And the only way to learn is to talk about it. And it's so much better for your own understanding to try to explain something to a friend. So that first class in college was one I think of that almost made me leave the subject. But then I had experiences like being at Smith, where everyone, it was a center for women in mathematics, which was incredibly empowering. And I knew based on my time in college and that time at Smith that I then wanted to seek out female supporting environments moving forward. So when I was selecting where I wanted to go to graduate school, I visited places and I counted the number of female graduate students that were on their websites and the number of faculty members. And I picked a place that was over half. Well, I don't think it's over half. It's close to half female graduate students. And that was very important to me.
Well, thank you for telling us all about that. I know a lot of us will really relate to that. I know I was in an advanced math class. I walked in, it's like, has everyone already taken this course? Am I like, did I miss the memo or something? And of course, it's just like me and like 2 other girls in this class. So definitely very relatable. Thank you so much for your presentation. I think next we're going to move on to our awards so we can see all our wonderful winners of our competition from 6th, 7th, and 8th grade. Thank you so much, Dr. Veal, for joining us. We really, really appreciate it. I love how you talk about how you can like combine math with baking. And I think it's cool how like math, you can really combine it with anything you love. I think that's one of like the cool features about mathematics. And can we get like a virtual round of applause for Dr. Veal on Zoom? And then I think I'm gonna start sharing my screen. And then we will pull up the presentation.
Thank you all so much. I'm going to leave my email address in the chat in case you want to follow up with me about any questions. It was a pleasure being here. Thank you.
Thank you so much. Thank you so much. Okay. So I would like to congratulate everyone who participated. I think it's good that you took the Saturday off, or you took the Saturday to do this test, even though you were required to. And I just want to share some statistics about our competition this year. So we had actually exactly 100 students participate in our test, and we have about 80 schools from around the nation represented. So I think that's very special. Okay. And next I want to introduce Annie to announce our 6th grade top 6 winners.
Okay, hello everyone. Like Marissa said, my name is Annie, and I will be presenting the top 6 for 6th grade this year. So first off, I would like to say congratulations to everybody who took the test, and congratulations especially to the people who made honor roll and to the people who made top 6 in each grade. Okay, so for in 6th place, sorry, we have Adeline Lay. In 5th place, we have Sophia Fan, and in 4th place, we have Elaine Gu. Congratulations to these 3. In 3rd place, we have Alice Yin, and in 2nd place, we have Raina Liu, and our top scorer for 6th grade is Laura Wang. So I would like you guys to congratulate these 6 girls for competing and making top 6. Next, I would like to pass it on to Emily, who is doing the top 6 for 7th grade.
Hey everyone, as Amy said, my name is Emily Zhang and I'll be presenting the top 6 for 7th grade. Before presenting, I would like to congratulate everyone who took the test because yeah, it's a Saturday and it's kind of, anyways. In 6th place, we have Summer Chu. In 5th place, we have Joni Jung. In 4th place, we have Valerie Fu. In 3rd place, we have Catherine Chen. In 1st place, we have Caroline Wong. And in 2nd place, we have Ella Liu. Congratulations to these 6 girls.
Hello, I'm Jerry Shao, and lastly, I'll be presenting the top 6 8th graders. Well, top 8, because there's a 4-way tie for 5th to 8th place between 4 people. We have Mia Liu, Alicia Lee, Riyaka Chopra, sorry if I mispronounced that, and Angela Ho. Next, for 4th place, we have Charlotte Liu. For 3rd place, we have Ashley Zhang. For 2nd place, we have Sophia Ho. And our winner of 8th grade and the entire MIG event is Ava Xu. Thanks everyone, and I hope you all enjoyed the contest.
I would also like to congratulate all the people who made the honor roll. So everyone who scored above a 15 out of 25 have made the honor roll, and we will send out an email in the coming days to all winners and all participants with awards, instructions, and a certificate. And then I want to pass it to Cindy with our upcoming MIG event.
All right, guys. So today at 6:30, we're gonna have the highly esteemed Dr. Lo. He's gonna be giving a speech on how girls can use math and science to succeed in life. And then shortly after that, we have 2 student high schoolers who are going to be going over the problems from this morning's test. To register for both events, you can refer to the email we sent out this morning, and then we'll also resend that link for you in case you need it. Also, we'd like to give a really big thank you to our generous sponsor, Connections Tutoring. They've been really, really helpful these past few years, helping us to create this event and give this opportunity to you guys. Also, thank you to the University of Memphis, the Department of Engineering, and Dr. Ivy for letting us use their classroom to stream this awards event. We're super thankful. All right, back to Marissa for the closing remarks.
Thank you so much, Cindy. And so that concludes our award ceremony. Thank you so much for joining us today. We hope to see you soon, maybe in another event, maybe next year. And you can follow us at our Instagram account at Math Invite for Girls, or YouTube, where our award ceremony will be posted later today at Math Invitational for Girls. And again, congratulations to everyone, winners and participants, for joining us today. And I hope you had fun and enjoyed our guest speaker, Dr. Viel, and doing our exam. And we hope to see you soon and have a nice day.